Hey, hi. In this video, we're gonna see how to host HashiCorp Vault on AWS EKS. As you see in this PPT, so this PPT depicts my demo. Here, I'm gonna spin up an Amazon EKS cluster. On top of the Amazon EKS cluster, we're gonna deploy the HashiCorp Vault with using Helm charts. So when you deploy that Helm chart, basically it's gonna create two types of parts. One is basically Vault parts, and the other one is the Vault agent injector part, right? And after that, we also use the another Helm chart, which is actually deploys the MySQL database on the Amazon EKS as a container image or container application. Now, the secure credentials that is needed to connect to this MySQL database, we're going to store that database details or database connection strings on the vault with using the required methodology. So here, the demo here focuses more on how to set up the vault, how to configure the vault, and how to store the the secret credentials that is needed for you to securely store on the vault, and then how to consume it as a consumer from the application side, right? So here in total we also host another example application which actually reads the credential. Okay, so here we are doing three steps basically. One is you are constructing the vault cluster on the EKS cluster, you are storing the required credentials on the vault, and then you are also deploying an application which will consume that or which actually reads the credentials from the vault, right? So in total the steps are something like this. First one, once we configure, the zero step here is we're going to configure the secure credentials or the credentials of MySQL database on the vault server, and then we also going to deploy our example application, right? And that as soon as we deploy the example application, vault agent injector will actually inject an the agent container on that application, so that it will help that application to interact with the vault and try to retrieve the credentials, or basically try to do the operations that you need to do on the vault. So that will be helped by the vault agent injector, right? Basically vault agent which is will be deployed along with the application. So in the step number 3, we're going to see that how this application interacts with the vault server or the vault parts, and then try to retrieve the required credentials which is stored already, right? And how does that use us for this application transaction purpose? So at a layman term, so we're going to see that how we can host this enterprise grade the secret vault on the EKS cluster, and how does we store it, how do we consume it, what are all the configurations we need to do. So that's all I'm going to walk you through here. So okay, so with that note, let me take you to my VS Code. So in this VS Code, I have done everything from the scratch, like from the creating the vault, from the creating the VPs, from creating the Amazon EKS cluster, then configuring the vault, then deploying the the credentials, then consuming the credentials from the application side. Okay, so we see those steps here one by one. I have already run these, so basically I have a list of commands here. As you see, I have documented this readme.md file. I have gone through the the HashiCorp Vault document, studied it, understood it, and I have documented this into a readme.md file. I'm going to share this readme.md file in the GitHub repository. From the GitHub repository, you can just consume it as as it is being written there. All right. Now, before you consume that, you need to understand how does this basically work. Okay, so here I'm going to walk you through those commands, help you to understand what is actually happening from the under the hood, and then we're gonna see that real time how we can retrieve the credentials from the HashiCorp Vault. So with that, so here I have documented all the steps one after the other in a serial order, and in the same serial order we have executed the command which I'm going to walk you through now. First one, you need to have the here prerequisite. You need to have the CLI installed, that is AWS CLI. You need to have the Helm installed in your system. You need to have the kubectl installed in your system, right? So then you need to have an IAM user in the AWS account with has the credentials, which has the permissions to create Amazon EKS cluster. So I am setting the AWS account context with running the command called AWS configure, and I provided these access key ID and the secret, you see. And then once I'm done with the AWS configure, or basically setting the context of my AWS account with using the AWS CLI, I'm just validating that. So validation is successful because it returns something to me, right? Then we go to the next command, that is basically creating the EKS cluster, right? So focus on my selections basically. So here we are using ekctl. So this is also a prerequisite that you need to have a ekctl utility to be installed in your system, so that you can use that EKS command line utility to create the EKS cluster. Okay, so since here the demo is focusing on how to set up the vault on the EKS cluster, so I've not used any Terraform, but I'm using the I'm using EKSCTL utility to create the EKS cluster. So here we are creating the EKS cluster with using EKSCTL create cluster. And you see that the name of my cluster is learn vault. Number of nodes, I'm keeping it 3, right? With OIDC enabled SSH key. So here to create a EKS cluster, you need to have a SSH key. You can create the SSH key by going to your AWS account. Currently, I am playing in region Oregon region. I have created a key like that is the key pair called learn vault. I have created that SSH key. So click on create key pair and use these options. Give your name of your key, right, and choose the the private key format like this. Click on create pair, which will create a key pair like this. So make sure that you have the key pair in your system, then only the EKS cluster will be created, right? And we created learn vault key, and that is being used here. And eventually it will take 15 minutes to deploy the EKS cluster. You see that it has successfully created the EKS cluster at this time. So not only that, when you use a EKSCTL command line, it actually updates the kubeconfig file. In the sense, it makes your current terminal context have the accessibility to that EKS cluster, which is just now created. Now I'm just checking whether I have the access to that particular cluster by running the command called kubectl get nodes. It has returned the 3 nodes, which means that my kubectl config, or basically kubeconfig file is updated, and I have an authorization to the API server, and I can interact with that. Next one is we need to create a service account, because here we are actually doing lot many things with the EKS cluster. So generally recommended to have the service account in the ES cluster, in the EKS cluster. So here we are creating an IAM service account. So the name of the service account is nothing but EBS CSI, a CSI driver. We need to install the add-on on this EKS cluster, that is EBS CIS driver, and for that it needs to have a service account, and that's the reason we are actually creating that service account as a prerequisite. So we are creating a service account of the cluster, and name is something like this, and this is being attached with a policy called something like this. Amazon EBS CS driver policy is being attached. So it creates basically it creates a service account for us, right? So it not only just creates IAM role, it also enables that IAM role as a service account on the EKS cluster. So once this is the output, once you see this output, which means that it has created a service account in your EKS cluster, right? Next one. So as I said, we are using that service account to create an add-on. What is the EKS add-on? Basically, you are actually installing the drivers in your EKS cluster, which will help the EKS cluster to do or basically to interact with the certain physical devices, like could be EBS or something like that, right? So here EKS cluster need to interact with the EBS drivers. So that's the reason we are adding this EKS cluster add-on on that EKS cluster. So command is very simple. So don't worry about the commands. I have documented all these commands in the readme.md file. The other relevant and reference file also will be shared in this repository link. You can find it from there. So we are creating an add-on that is of type, you see, EBS CIS driver, and pointing to the cluster. This is the cluster, and service account, which is account which we created above. That's the service account. So once the add-on is done, we are done with the setting the EKS cluster. Now next command is we actually need to install the certain prerequisite. Okay, so here we want to deal with the credentials. We want to deal with the credentials of what? We want to use the MySQL, or we want to store the credentials of database on HashiCorp Vault, right? So for that case, we're going to use the Helm chart to deploy the MySQL pod in the EKS cluster. So here we are actually adding the repository of Helm chart, that is Bitnami. Helm chart will be added here. So run this command, which will actually add a Helm chart called Bitnami in your local system, right? And then next one, we are actually running the MySQL Helm chart to install that. In the sense, run Helm install MySQL and pointing to the Helm chart repository name, that is bitnami/MySQL, which actually, if it returns something output like this, which means that it has created a pod in your EKS cluster, which is nothing but MySQL pod, or basically you install the MySQL application on the EKS cluster as a pod. Now with that configuration, we will go to the next command. So next command is, I just wanted to validate whether the the SQL, in the sense MySQL a pod is running or not. So I just ran called kubectl get pod. So, and it was showing me something like this. You see that in the ready state it is 0 /, in the sense it is, even though it is running, but it is not at ready, right? So it will be ready after some time. So again I run the command after after a milliseconds, and then it give me the response. Yeah, so which means now the MySQL pod is ready. So now MySQL is basically an the RDBMS service. So this is basically used, it will help your application to store the backend. In the sense, this application is acting as a backend database for your application, right? It can store your application database. It can store your the basically your application transaction data can be stored in this database. Now to connect to this database, you need to have a secure string. Now how do you use that secure string, right? So we can store this secure string on the HashiCorp Vault. That is the use case here. Let's see how we need to do that. In the sense, we store it on a HashiCorp Vault, and how to retrieve from the vault in a very secure manner, right? So HashiCorp Vault provides the enterprise grade the secret vaulting. In the sense, it actually manages the lifecycle of the secret entirely, right? And helps the consumers of the secrets to consume the secret in a very secured manner. So we use the kubectl service. In the sense, later once it is done, I'm just exploring the services. You see that we have MySQL services also been installed, right? And then next one, that is I need to retrieve the root password of the of the MySQL database, right? For that case, I run a command called kubectl get secret namespace default, and the pod name is MySQL, and from there I need to get the root password, right? So when you deploy a MySQL pod in the Kubernetes cluster, it will have its own root password. In the sense, it will have the root credential through which you can log into that MySQL instance, and that password I'm retrieving it here with using the kubectl command, right? So when we install the MySQL database with using the Helm chart, it does configure all the components of the the MySQL application, right? It configures the server, it configures the config maps, it stores the secrets, right? So basically it actually configures end-to-end configurations of the MySQL. Henceforth, I'm just retrieving the one of the component of the MySQL called secret. So to do that, I did some exercise. Previously my system was not installed with the base64 encoding. So for that case, I did something like, since this system is Windows, so I did some tricks. That is, first I retrieved the credentials, something like this. Yeah, so this credential is stored in this one, but this is in a base64 encoded. Now I want to convert into a decoded format. So for that case, you see that. So then we have I did these these Windows PowerShell tricks, that is converting from base64 encoded to to a plain text, right? So, and this is are the commands I'm running to basically decode it. And here is the decoded string, and then I'm storing that value to a root password. So here I was supposed to do it here. For example, say if you are running these commands in a Linux system, or say in the Mac OS, you don't need to do anything tricks which I'm doing, but it will happen as it is, right? So now we have a root credentials of the basically of the MySQL application. Okay, so now what we did is we set the EKS cluster, we set the one secure application, that is MySQL, as a container application, and that pod is running. We retrieve the root credentials of that particular pod. Now let's see what is the thing I'm doing. So next one is we need to install the Vault on the Vault application on the EKS cluster. Let's see how to do that. So for that case, again, we need to update our Helm repository, because I'm using the Helm repository to create the Vault application. So we are updating the Helm repo, add HashiCorp, and pointing to this HashiCorp chart URL, right? And then we are actually doing the Helm repo update, and then we are actually searching the vault. In the sense, so basically when you do a Helm, basically when you do a Helm repo add, in the sense, you're actually basically forking the the Helm repository in your local system. Then you are actually updating the local repository that is present on your system by running the command called Helm repo update. Now from that repository, you are checking, do you have a particular repository called what? A particular repository called Vault, right? So that is Helm search repository. So it is basically giving you so many options, okay? Because since I have added the Helm repository belongs to HashiCorp, so it has given so many repositories belongs to Vault. Now in that repository, we're going to use particular one, okay? So for that case, next command is this one, and follow the selection, that is Helm install Vault from the chart like HashiCorp Vault with using this particular values. So for that case, I have the value file. So this is the value file I'm gonna show you that. So if I can make down, so this is the the Helm Vault raft values. Basically, it is actually when you install the Vault on the EKS cluster, you're gonna give this as a value files, in this value you can actually enable the certain features, like basically you see that highly available raft configurations, everything can be modified according to the need. Yeah, so we have used the default values here, not changed anything. So we're going to go up and we see that we are passing that, in the sense while installing the HashiCorp Vault, I'm using that file, yeah, that YAML file as a value file. Now you see that, so there was some error, because remember that this error is also a learning for you. So because previously my YAML file was not in a required format, so it threw in the error. Later I modified the YAML file. Now whatever you saw that YAML file, it is a correct YAML file, you can readily use it. Then we run the command, that is helm install vault, which actually installs the helm, the pods or helm application on the EKS cluster. So this much is the, so whatever I have selected, so that is basically is the output of helm install vault. And then I suddenly change, again checking the kubectl get pods. You do one configuration, then you need to validate whether you are done with that or not. Yeah, so we are actually running the kubectl get pod, which is gives you these many outputs. Now we have, you see that how many parts do we have for vault? So we have 3 parts for vault, and one is nothing but the default agent injector pod as well. I'm going to explain what is the agent injector pod. This basically, as the name says, it's actually whenever new application or new parts are spinned up, this injector pod, it actually configures the certain configurations of that on that, the pod actually. Yeah, so this is the currently in current context of namespace. So we have these many pods. So if you can observe here, you see that our vault 0 to 1, both are running, but they are not yet configured correctly. But while the vault agent injector R is ready and it is readily configured. Now we are installed the vault, we need to, that is not enough, we need to configure the vault application, right? And for that we need to do a certain steps in the kubectl. That is the next step that we're going to do it now. So first one is, we actually need to check the status basically. Yeah, so to check the status of the vault, what we do is we're going to run the kubectl execute. So basically we are actually logging into these parts and try to configure the required configurations. First one is to check what is happening on this particular part, that is on vault 0. So here you see that the output, in the sense the output is basically a dictionary, contains a key value pair. It says that it is initialized equal to false, and it is shielded, in the sense by default whenever you install the vault software on your EKS cluster, by default all the parts are basically in the sealed format, and these are all not initialized. Okay, so you need to configure those parts in a such a way that should be initialized and it should not be sealed, and that is the next step that we're going to do now. So basic, the next command is to basically we need to basically start the operations of that vault. So those commands, if I can drag down these. So here I'm going to show you that in the output as well. So if I go to the source code here, and we have the readme.md file. So here if I go up to the up again, so once this is basically at the HashiCorp repository, we installed it. Yeah, and then basically here we actually initialize the vault with 1 key share and 1 key threshold. So basically I have given the required information about what is that command is doing, even in this readme.md file. You can find it from there. Now quickly we're going to go to the next commands basically and try to see the how does it works next. While I'm going to open this now, let me do this one basically. Yeah, so where were we? So we were here, that is in the command, and if I go back to the above, that is here, that is initialize the vault with 1 key share and 1 key threshold. Okay, so basically as I said, once you install the helm repository for vault, you need to do the next step. That is nothing but first step is to initialize the vault with 1 key share and 1 key threshold, and that is what these commands does. You see that if you see the kubectl execute vault 0 operator, in the sense you need to run this command, that is operate init with the key share equal to 1 and key threshold equal to 1, right? So basically what is nothing but so here we are actually getting the cluster keys from this vault 0 part. We are actually getting the required secrets of the vault, in the sense the what I can say, you have the vault, and when you first time configure the vault, it will actually have the keys to authenticate. Okay, so that's keys to authenticate will be taken in a JSON file, that is cluster keys, right? So this is the command which when you do operator init, you can actually the get the keys and store it in the form of a JSON. So when I run this command, it actually generated a JSON file, which is I'm going to show you right away. So this is the JSON file, it got generated. You can see this JSON file as it here. So it is nothing but it is a kind of the dictionary here. It contains the unsealed keys in the form of hexagon, right? Then it also has a root token as well. So we need these information for the next tasks, right? For that case, let's go to the next command. So next command is basically get the vault unsealed key. So now we have generated the cluster-keys.json file. You see that. Now from that JSON, I need to get the value that is vault unsealed key. So if I go down again to the JSON file, so this file has the unsealed key. You see that unsealed key in the base64 format, and it has a root key. So we need that information in a variable, and for that case, we are running the next commands to do that. One is here, you are setting the variable called vault unsealed key by running this command, right? So since this is a window, so I'm not using the jQuery. So basically, I have installed the jQuery in this Windows system. So that's the reason you see that it is now jQuery, in the sense JQ, in the sense it is like basically it actually does the regular expression search and gets that particular value from that file, right? And since I've installed that binary of this JQ, now it has been running. And when I run this command, that is cat cluster keys.json, it is actually retrieving the value. So this value you can find it from the here, right? If I go to the file, so ending with HOQ, right? So this is the file, this is the value that we see here in this as well. Okay, so that is what we did here now. Next one is basically we need to have the unsealed key, right? So this is the unsealed key. So that is being stored in a PowerShell variable. This is currently I'm running in a PowerShell terminal. So remember that. So my variable will be starting with dollar and the name of the variable, and that is being output here, right? Okay, so that is the command we have done. Basically, in a sense, now we initialize the pod. In the sense, we initialize the vault pod, got the required cluster keys. That cluster key has one unsealed key, one root key. Now we have stored the unsealed key in a particular variable. Now next, we're going to use the unsealed key to actually unseal the operator, in the sense unseal the vault, right? Unseal the vault running on the pod, that is vault 0. To do that, we have to run one more command, that is something like this. This is very simple task, right? First one is you're going to run an execute command on the vault 0, and this is the operator in it. With these parameters, you're going to have the cluster keys. From the cluster keys, we're going to use the unseal key and run this command to unseal the vault operator, in the sense unseal the the operator. So basically unseal the vault, that is nothing but a server of a cluster like that, yeah, a server of a vault cluster like that. So basically these are all nothing but predefined tasks that you need to do before you consume the vault server. So here we are actually unsealing that by using the key that we have retrieved. And as soon as that, you see, if you run the command now, all right, so now automatically the value of that the vault 0 changes, right? You see earlier it was initialized equal to false, sealed equal to true. Now it is reversed, in the sense it has now unsealed and it is basically initialized as well. Yeah, so we saw that command just somewhere here, that is we just check the status, right? Now we are actually doing the now we did with using the unsealed key, we can see that it is unsealed now, right? So right now we did play with this only one vault, that is vault 0 part. Now we have another two part as well, that is vault 1 and vault 2. We need to unseal those parts and also basically initialize those part. Okay, so how do we do that? That is the next steps. So next one is basically you actually checked that now the vault 0 is unsealed and initialized, right? Next one is the next task is to join the other vaults to this vault cluster, in the sense join the other vaults to this vault cluster, right? Now what we did is we made vault 0 as the primary server of the cluster, right? So cluster is nothing but it's a collection of pod here. Okay, remember, don't get confused. So it is a collection of pods. It is nothing but vault 01, vault 0, vault 01, vault 02 are nothing but collection of the vault cluster pods. In that one we made vault 0 as a primary. Now we need to do with the same with the vault 1 and vault 2, so that we provide a highly available vault capabilities. So then kubectl execute vault status, we did that, right? And then basically display the root token. So now we need to deal with the root token as well. So I showed you the root token in that one. So basically you see that so this is what we did. This is the since I run the command wrong, so here I run the command, that is cat from this file. So we have that root token. If I go back to this one, so this is the root token that is getting displayed here. I did a $cat, so it is throwing the error. That's, you can forget it. Now what we're doing is we are actually creating a one more variable, that is PowerShell variable here, because my terminal is PowerShell, with using the $cluster root token. So that is nothing but, we are actually creating a one unsealed key, the other one is root token. We are keeping it at two variables, which is needed for next tasks. So our cluster root token is being stored in the cluster here by running this command, which is nothing but reading that JSON file and making it as a variable. Now down the line we are actually doing the next command, that is actually basically, now what we do is we need to, now we made vault 0 as a primary pod. Now we need to log into that pod. So you can do a login to that pod by running the command kubectl execute vault 0 vault login and give the cluster root token that we have opted from the file. Okay, so if I go this one, that is login with the root token on the vault 0 pod. Now by after login to that vault, we need to do further commands actually. So let's see what we need to do. Next one is list all the nodes within the vault cluster by using pod 0. Right, so now next command is to basically list the peers. Okay, if I go here, so okay, so before we go to the next command, try to study this command. Okay, so what is it displaying? So it displays these information, that is, you are now authenticated. The token information displayed below are already stored in the token helper. You don't need to run the vault again, right? Because you are already logged into the cluster. That's what it means. The future vault request will be automatically use this token. That's what it does. Yeah. So this is very important point, that you have now logged into the cluster. Now the context, in the sense, this PowerShell terminal session is now already in a vault session. Okay, remember that. Okay, next one is basically just to list the peers. Okay, so what are all the what are all the nodes that are available in that cluster? So to do that, we are actually running the command, that is kubectl execute vault kubectl execute vault 0. So which actually so if you see that, to basically kubectl execute command vault 0 -f vault operator. Basically after this, these are what are all the commands that you put. That is nothing but those are all the commands which is actually does the operation. That is nothing but here raft list the peers in the cluster. So these are all the peers. Currently we have only one peer, that is vault 0. As I said, since we logged into vault 0 as a primary pod, and that is now considered as a leader. Okay, and the next one is so basically this is this is the mechanism of the cluster, right? So how does the cluster works? And these are all the these are all the cluster terminology, which I'm not going to go in a deeper. Right, next go to the next configuration that you need to do. That is nothing but join the vault server, in the sense join the vault server on the vault 1 to the vault cluster, in the sense, now when I list the all vault parts, so we had a 3 parts in that one. We made one part as a leader, one part as leader. Now we have a 2 more parts, that is vault 1 and vault 2 has to be added to the vault cluster. To do that, we are actually doing the next command, that is basically running these very simple command: kubectl execute vault 1 vault operator raft join to this particular HTTPS value. That is nothing but join to this particular pod as a basically as the next node in the vault. Yeah, like that. So it should return something like join and true, right? And then we're gonna go to the next command. So joining is not enough. You also need to unseal the server present on the vault 1 pod using the unseal key. This is what we did for the vault 0 as well. So we're gonna do the same thing for here as well. That is kubectl execute vault 1 vault operator unseal, and this is the unseal key, which is nothing but we retrieved from the vault 1. So you see that automatically the value will get changed. So these are nothing but these are the output tells you that you have done the job correctly. So this is basically predefined steps or predefined configurations that you need to must install or must run to set up the cluster on the EKS cluster, and that is what I'm walking you here, right? Similarly, we do the same thing for vault 2 as well, and it will give the output. Okay, so once you are done with this, next command is just check the peer results. Okay, if I go down now, once you attach to the vault 2 as well, now you run the command, that is kubectl execute vault 0 vault operator list the peers. So now you see that earlier it was only vault 0, now it is returning 3 vaults, that is vault 0 1 and 2, where 0 is the leader. And the next command is, now let's run now you are actually configured the vault configurations. So basically till now you install the vault pods by using help chart. You configure the vault pods in a such a way that they actually operate as a cluster. Now once you run the command, that is kubectl get pods, now the result will be something different, which is the expected one before you consume the vault cluster. So that is vault 0 and vault 1 and vault 2. Basically, you see that value, the ready state is now changed. Right now it is ready, running and configured as well. Next command is basically now we are now set with the vault cluster. Now it is time to consume it. So in the consumption part, you have a step number 1. One is you store the secret. Step number 2, you consume the secret. Now let's see how to store the secret. Yeah. Next one is now create a database. So okay, so create a database role. So to create a database, basically you see that enable the database secret at the path. In the sense, here is create a vault. So basically, here you are actually create a database role. It is nothing but here we are actually storing the secret of my database on the cluster. As simple as that. So here to do that, you need to run a big command. So this is basically what I did is, before creating a database path, I directly try to configure the secret. That is how it will not work, and you see that it is thrown the error. Basically, these are all the learnings for you again. So before you write the secret, you need to create a secret path in the cluster, and that is what the command this will do. That is kubectl execute vault 0. Remember that every configurations of the the secret read and write will be happening on the primary server of the cluster, that is vault 0. So here we are actually secret enable. In the sense, we are actually creating a secret path by a command called secret enable, right? So in total, this is the command. So it actually says success enable the database secret engine at the path database. Yeah. So that is basically creating a secret path here. So on the cluster, we created a secret path called database. In that database, now we need to store the, basically we need to create a secret engine and store the credentials in that engine, right? That is basically configure the database secret engine with the connection strings off for the MySQL database. That is a big command. So this is what it command does. I'm going to show you in the command later. Okay. So when I run this command previously without creating the, the database secret engine path, it thrown the error. Now, once the database, the secret path is ready, you can configure the, the secret engine, right? With the required credential, required connection credentials. So here kubectl execute vault 0. Here we are actually executing the write this database secret path, right? This is nothing but vault secret path. In that one, you are configuring the MySQL. In the sense, configure a MySQL credentials. The plugin name is MySQL database plugin. These are nothing but these are all the parameters to basically configure the database secret engine. Okay, and this is nothing but it is syntax oriented. We don't have any magic here, so you need to follow the syntax. So here you need to give the plugin name, you need to give the connection URL, that is nothing but database connection URL. You need to do a allow roles, that is read only role should be allowed here, and the username is here, which is basically root, because as you know that the username of the root username of the MySQL database is always root, and the connection string is nothing but here. Yeah, that's what the username and password is being given here. Okay, so basically you are actually storing the connection URL as a secret on the vault, and that connection URL will be consumed down the line. Let's see how are we doing. You should be able to see the output, that is nothing but success data is written to the database. Okay, now we are done with the step number 1, that is nothing but storing the connection string on the EKS key vault, EKS HashiCorp Vault. Now next command is basically now vault vault credentials are stored. To consume that vault credentials, you need to also do a certain configurations. What is that? You need to define a role, right? And so basically you need to define a role which can consume that secret. Okay, for that case we have to do a next step, that is create a database secret engine role. In the sense, we have created a database secret engine. To that we need to have a role. So that can be done by this one more big command. Here you go here. So we have a big command like this. So here, that is kubectl vault 0 write a database role with the name read only, and that is what we have configured while while creating the database secret engine. Now to that engine you are creating a role, right? So you need to give the proper naming convention, and that should be aligned. In the sense, whatever the role you gave while creating the configuring the database engine, that role has to be given same while creating the engine role, right? So here engine role is nothing but read only role, and the database name is MySQL. The creation statement is nothing but it's creates a user. You see that these are all the nothing but commands that you need to run. Yeah. Okay, so then here actually you are giving the TTL, that is time to live, and then maximum time to live equal to 1 and 24 hours respectively. So with this you are actually created the database role, that is nothing but database secret engine role with the read only name. It is being created now. with that role, can we try to access the secret? That is the next the experimentation that we're going to do. Read the credentials from the cluster, the read-only database, with using the read-only database. Okay, so let's see whether we can do that. That is, kubectl execute vault, read the database, read database creds, that is read only. Okay, so you see that it actually return the value, that is nothing but, you see that lease id is blah blah. So here basically what you are doing is you are actually reading the credential that is stored in a vault, and it is indeed, it is giving the response. You see that lease id, lease duration, lease renewal, password, and username. So all these been given here, which means that we have stored the credentials and we have configured the basically the engine role named read only as expected. Yeah, so now we are done with that. Next one is we need to go from the consumer side. To consume the credentials within the EKS cluster, you need to do one prerequisite, that is configure the Kubernetes authentication, right? That is where the next job is, that is configure the Kubernetes authentication. So okay, so let me go to the next one. All right. So Vault provides a Kubernetes authentication mechanism that enables the clients to authenticate with the Kubernetes service authentication token. Yeah. So this is basically, before you consume the Vault, you need to do a certain prerequisite configuration. That is what we are doing now. To do that, basically you need to log in into the, the Vault 0. That is nothing but, primary server of the cluster of the Vault, and try to do these configurations so that you actually configure the certain things in the Vault so that it will allow the other parts in the EKS cluster to consume the credentials. So for that reason, we need to do a kubectl execute, basically log in into the Vault. That is nothing but, here now we are logging into the Vault 0 part. In the sense, you are actually taking a session of that particular part and doing the next configurations. So this is the command which actually takes the bash session of the the part 0. Next one is we are actually running a very blunt command, that is nothing but enable the Kubernetes authentication method. That is vault auth enable Kubernetes. Okay, that is what the command we do. So you see that now my terminal has changed to hash. When it happens within the, basically it will happen within the bash terminal. So here we are actually doing the vault auth enable Kubernetes. Okay, and you should be able to see that the enable the Kubernetes auth method, that is Kubernetes. Okay, the next command is the configure the Kubernetes authentication method, use the location, something like this. Okay, so next command is this one. So I'm just running those serial of commands that you need to do from the Vault 0, and you should be able to see this particular response. Yeah, so likewise, then the write out the policy named web app that enables the read capability for the secret which is stored in this particular path. Yeah, so we're going to host an application called web app after these commands, and that application has to be allowed to read the path from this particular credential. That's what we are doing now. So, and that is nothing but, basically you are actually creating the, the vault policy which can allow the web application part to read the credential from there. And that is what here is, it is what it's happening here. Okay, so that is nothing but, this is the command which I run. That is vault policy write web app, particularly this path, and we are giving this one. Okay, and then here it actually basically uploaded the policy as expected. Okay, so then what is that next we are doing? So next one is basically create the Kubernetes authentication role. Next one is we need to create a Kubernetes authentication role. So the next command is this is the command, that is vault write authorize the Kubernetes role, that is web app, right? And that is bound service is nothing but internal app, and bound service account is parameter equal to default. So basically this is, it actually creates the Kubernetes authentication role named dev web app within the basic here, so you must know that, the how does the vault work, right? To consume, so you have created a secret. To consume the secret, you need to create a role and policy. That is what here we are doing. Here we created a policy so that we allow the application to read the secret stored in a path. And the next one is, to that policy we are actually attaching a role, that is which actually nothing but, Kubernetes authentication role, and it should give a response that is nothing but data return, that is you have added a role within that. Okay, so with that done, with that basically you are done with the Kubernetes authentication steps, and you can do a exit. In the sense, when you do a exit, is nothing but you are coming out of the part 0 which we just now logged in. Now let's go to the next command. Next command is basically, now we are done with the storing, we are done with the configuring the the secret in a such a way that it can be consumed by the application. Now we need to run the application, deploy an example application with a certain configuration that it can read the credentials from the vault. So first one is, we are actually deploying the internal app. I have a YAML file which I'm going to show you right away. So here is the internal app is basically nothing but, it creates a service account. When I run this particular, the specification file, it created a service account. The next one is basically the dev web app, that is nothing but development web app. If I open this one, this is another manifest file of Kubernetes. It actually kind is nothing, you see that it is a pod. You have a metadata, you have a label, the annotations. Remember that annotations are basically major player of the in the sense it is a major configuration which actually enables to consume the credentials from the the HashiCorp Vault. So you need to give all these annotations as expected, and it basically does two main things. One is it injects the agent, it enables the cache, you see, it also enables a role. Then it also runs a certain script which is needed, right, which will actually helps us to experiment the authentication. Yeah. So basically what happens is this is nothing but it's an example part which actually be deployed on the cluster, and with using that part we are actually realizing that whether can I connect to the vault and retrieve the credential. So now once I run this one, it actually deployed a pod. Then I want to check whether the pod is deployed or not. You see that I have a huge list of pod now. This is our consumer part, that is nothing but application part, which consumes the application from the vault. Basically that is nothing but HashiCorp Vault. So here after that basically you see that we also have the lot many other vault, that is vault 0, vault 1, vault 2. So you see that all these vaults are basically in a running state. Yeah. Now what is that we did a deploy a pod called web app. If I go to the definition of this one, you see that here is the web app, and these are all the configurations we did. So what happens is when I deploy this particular web app, it actually runs a script which actually retrieves the the credentials. Okay, and you see that okay, so if I once after deploying this dev web app, I'm not going to go to this file very deeper. You can do it from your side. Once you deploy this part, next one is display the secret that is written into this particular the basically when you deploy this particular path, it actually creates the creates a path called database connection string.sh. I need to get the output of what is the content of that particular file. Okay, so what is this file is, when I deploy the dev web app by using that particular YAML file, it creates a path something like this within that, and in that one you have a file called database connect.sh file, right? And from that file I need to get the connection string. Okay, so for that case we are just running the kubectl execute command, which actually executes the remote command on the pod, that is kubectl execute, right? Standard input equal to true. This is the web app in the sense in this container pod, and we are actually running the command that is nothing but cat this file. Yeah, and here you go, right? So if I run this command, if I select this part, so this is what we are doing it. I can do it again one more in front of you. So if I run this command, it actually basically log into that particular part and doing a cat of this file, which actually stores the secret of, in the sense that it actually stores the the connection string of MySQL database, which is stored in the vault, and application is able to retrieve that. Okay, that is the main important thing here, right? So here you go, right? So basically you see that we are able to retrieve the connection string. The password is this one, then you have a username is this one, right? And then the host name is this one. This is my host name of my pod. This is a username, this is a password, and database is my database. Yeah, so this is what we got, right? All right, so with that note, I know I have shown you the things need to be shown in this video. That is nothing but from scratch, like how to set up the vault cluster on the EKS, how to set up the vault configurations, then how to store the secret of a particular the application on the vault. Then how does the the consumer has to be set up in a such a way that it can read the pod from the, it can read the credentials from the vault, and then can be used for application lifecycle purpose. All right, so with that note, I have shown you the things need to be shown in this video. Finally, I can't request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you, thanks a lot, and see you in the next video.